Okay, welcome to Naming Acids. You will need your notes package open to page 32 as well as your data booklet. Your data booklet needs to be open to page 5. Top of page 5 has the rules for naming acids. I will do my best to write the names of these formulas the best I can on a Word document. Might not be the most accurate because I don't have a pen that I can write with, so please bear with me. So ionic compounds are going to dissociate in water to create ions. Now keep in mind, ionic compounds are only going to dissociate if they're soluble in water, which means that you need to use your data booklet, your solubility chart to determine if it is actually going to dissolve or, sorry, dissociate in water, just like we taught you, or just like I taught you in the first chapter. Sorry if I am a little not straightforward. It is 12 a.m. and I am making this video for you. It is saying show the dissociation reaction for gallium sulfate found in water. So what we need to do is we need to find a formula for gallium sulfate. So gallium has a +3 charge if you look in your data booklet. And then sulfate has a -2 charge found in your polyatomic table. Common factor is 6, which means that we need 2 galliums as well as 3 phosphates. So again, this is going to be really hard to write down. So you will get Ga and then 2. That has to be a lowercase 2. Please write it correctly. And then SO, and then lowercase 4, close your bracket, and then you should have 3 of those lowercase. Also lowercase should be the fact that it's a solid, and then you draw an arrow. Now you have to determine whether or not it is soluble in water. Now hopefully I picked one that was soluble in water, so you find your SO4, which is right here. Determine if gallium is soluble with it. It is not found down here, so therefore it's most, and that means it's soluble. Woohoo! So now that means I need to put my ions, which is gallium, with a superscript, so up top +3. It is aqueous in water, plus my SO lowercase 4 with a superscript -2 and a lowercase aq. Again, I am really sorry, but this is the best I can do. Make sure it's a balanced reaction. So remember, over here we have 2 gallium and then 3 sulfate. So you need to put a 2 and a 3. Okay, just to balance that reaction. And again, this is very beginning of this unit, so it's back in the first couple of sections of your notes package. So that is ionic compounds, and that's what we've been working with in the first chapter the majority of the time. So when molecular compounds dissolve in water and separate, so I told you that they didn't, when in reality they do, or at least some of them do. So when molecular compounds dissolve in water and separate, the process is actually called ionization. So ionization occurs with acids, and they're balanced like any other chemical reaction. So what I have here is hydrogen fluoride. So it says show the ionization reaction of the following compounds. So here we have hydrogen fluoride. Actually, you know what? I'm going to skip this and I'll do this on Friday. We're just going to go down to the science 10. Please remind me on Friday to go through that because it'll be way easier. Okay, so in science 10 you learned the difference between acid and bases. So acids have specific properties, whereas bases have specific properties. So you should know the pH scale from grade 10. So acids have a pH of less than 7 and bases have a pH of above 7. Whereas if you have a pH of 7, that is telling you you are neutral. When we are looking at indicators, more specifically litmus indicator, litmus will change red in the presence of an acid and blue in the presence of a base. But when you use litmus, the key is you have to use both red and blue litmus to test, because it could be neutral. So if your red litmus stayed red and your blue litmus stayed blue, then your pH would be neutral, which would be a pH of 7. Both acid and bases conduct electricity at the extreme ends of their scale. So lower pHs and higher pHs will conduct electricity. Acids taste sour, so lemon, lime, whereas bases will taste bitter, so things like milk, for example. And then both acids and bases are aqueous, which means they are a solute dissolved in water. And then acids will react with metals to make hydrogen gas, uh, whereas bases, when they're dilute, become slippery. So almost, if you think about mucus, and you get mucus on your hand and you rub it between your fingers, or oil, that would be what slippery is representing. So bases are ionic compounds just dissolved in water, so aqueous. So you would do your reactions, your dissociation reactions, just like you did in the first chapter, and you name them like ionic compounds. So the rules for those guys shouldn't be too challenging for you. But acids have a different set of rules. You should have learned these in grade 10. And I tell students to name them like ionic compounds and then convert it to the acid name. It is just so much easier. All acids are going to have a hydrogen at the beginning, and they are all aqueous, which means it should be AQ at the end. So this chart is in your data booklet. So page 5, top of page 5. So you do not have to memorize these rules. They are there. You just need to know how to use them. I cannot tell you how to use them on a test, so you need to learn. The two more common columns that we're going to use are the first two, where it says the ionic name and the acid name. So if you know hydrogen, if you have a name or a formula and you write the name as its ionic compound name and it becomes hydrogen blank ide, you change the hydrogen to hydro and the ide to ic acid. So we're going to do some examples, and then same thing for the last two. So when we do some examples. So here we have HBr. So again, name it like an ionic compound. So an ionic compound, this is hydrogen bromide. So you ask yourself, does it look like 1, 2, or 3? So to me, it looks like 1 because it's hydrogen and then it has IDE at the end. So what you're going to do is you're going to get rid of the hydrogen. So you're going to cross it off. You're going to get rid of it, and you're going to put hydro. You're going to get rid of the IDE and put ic acid and smush it all together. So now I have hydrogen bromic acid. Sorry, hydrobromic acid. Again, it's 12 a.m. Sorry. So hydrobromic acid. I just realized I did that one wrong. I am really sorry. It says it's a gas. So since it's a gas, we do not use the acid name. See, it says gas here. So this one would stay as hydrogen bromide. So you can highlight that. That one's hydrogen bromide. Everything I just did here is number 2. So since it says aqueous at the back, that one is representing the fact that we are an acid. So this one will be your hydrobromic acid. Okay, so I'm going to skip to number 4. Number 4, it says sulfuric acid. So remember I said use the first 2 columns. Sulfuric acid, find one that matches. It's not number 1 here because I don't have hydro. It doesn't say hydrosulfuric acid. Okay, so can't be 1. number 2 says ic acid. Okay, so I do have ic acid. So what I'm going to do is I'm going to get rid of ic acid and it's going to change to 8. Now, sulfur and phosphorus are 2 exceptions to the rule for naming acids because they like to keep the UR and the OR for phosphorus and sulfur. So instead of becoming sulfic acid, it's sulfuric acid just because it's smoother in saying the name. So this one does look like number 2. So ic acid changes to 8. So we have sulfate is the name. And then we add hydrogen to the beginning. So we have hydrogen sulfate. And do we know how to name hydrogen sulfate? We should, because it's an ionic compound. So if it's an ionic compound, hydrogen has a +1 charge, sulfate has a -2 charge. Okay, and you can write your +1 and your -2 above them, and then ask yourself, what do you need more of? You would need more hydrogens to balance it out. So I would need 2 hydrogens, lowercase 2, and then sulfate, I would only need 1, which is SO4. So this one's H2SO4. Okay, number 5 says hydroiodic acid. People say this hydroiodic acid. So hydro is that number 1. Okay, so hydro changes to hydrogen. I put a space, and then my ic acid changes to ide. So IO, and then get rid of ic acid and put IDE. So hydrogen iodide. And then I name it like I normally would for an ionic compound. Hydrogen's a +1, iodide is a -1. So that means I get HI. And technically I put AQ at the end of all of them. Okay. Okay, my next one down here, number 3, sulfurous acid. Sulfurous acid looks like number 3 here. So that means I'm going to change the OUS acid to ite. And remember, sulfur and phosphorus are exceptions. So if I sound it out, sulfurous, sulfurite, is there anything sulfurite? No. So get rid of the UR, sulfite. Sulfite is a polyatomic ion, so you're going to add hydrogen to the beginning. Okay, so sulfite, go back to your polyatomic table. This is not one we use very often. Usually it's sulfate that we work with. So sulfite is right here. Sulfite is SO3 -2. So if I have SO3 -2, then I need 2 hydrogens to balance that one out. So it's H2SO3. And again, lowercase 2 and lowercase 3. You need to practice these. I will do these examples with you on Friday, but you need to have this table on page 34 attempted, and I need to see it attempted. I will do a homework check on Friday. Okay, and once you've attempted this, you can start working on your chapter assignment.